All right, good evening, everyone, and welcome to our next session. Today, we are going to be talking about elastic load balancers. So, what is an elastic load balancer, and what does it play in the cloud? What is its role? So, simply put it, an elastic load balancer is a service which uniformly distributes network traffic and workloads across multiple servers. What do they mean by this? Look up here. This is the internet. This is a load balancer. These are savers. These are savers. Now, here you are in a cyber cafe somewhere or on top of your laptop. You are trying to get an information from this server. You are trying to get an information from this server. Let's say you are somewhere, you are sitting here, the information you want to access is found in this server. What will happen? You will first of all have access to the internet, then the internet will have access to a load balancer, the load balancer will have access to the server. This is the actual caricature that happens. Let me show you something here. Okay, normally speaking, look closer here, please. Normally speaking, this is what happens. This is what happens. Your saver is found behind here, then the internet is found here, then your laptop is found here, where when you launch when you launch request to the internet, that request goes to the internet, and then the internet routes that request and sends it to the server, and then the server now sends back your information, and then the information comes back to you. This is how the normal thing is. This is how it normally occurs. That's how the normal architecture of the internet functions. When you send request to the internet sends that request to a server according to the DNS of that server. It sends that request to a server, and then the server responds back. The server responds back to you. This one is sending information to the server. Information to the server, and then information back from the server. So this is a normal caricature. This is what happens. When you send information to the internet sends the information to a server, then the server itself sees what you need, sends it back to the internet, and then the internet sends it back to you. That's how the caricature. But now, here is the problem with this architecture. Here is the problem. This server like this very particular server like this, can only hold around 20 people at a particular time. That means, what do I mean by 20 people? That means if there are more than 20 computers here that are asking for the same information, if there are more than 20 computers here and all these computers, they want to have access to this server, the server will crash, and the time for the information to come back will be too slow. That is, the time will be large. That means that type of a situation where you send information, the information goes to a particular server, and then it does not come back very rapidly. Why? Because the server is meant to have just around 20 traffic, 20 IPs per at a particular time. Okay. So how can we solve this situation? Let's take for example, you have your website, or you have your e-commerce site. This is your e-commerce site. Now, people are always coming to buy from your e-commerce site. You are selling things online. People are coming to buy. Let's take for example that you are selling courses in video form, and people always come and buy those courses and go away. Now, if at any one time only 20 people can have access to your website at a particular time, right? If only 20 people can have access to your website at that particular time, then I mean, you have a website that does not have an inflow, it does not have traffic, you are comfortable. So if ever there are 10 people that wants to visit your website, it's okay, everybody will be saved at the same time. If there are 15, it is okay, everybody can visit it at the same time. If there are 20, it is okay, all of them can visit it at the same time. But what if there are 21 people? What if there are 21 people? If there are 21 people now that wants to visit this website, 20 will have access to this website, and the one person that is remaining will not be able to have access to the website. Why will he not be able to have access to the website? Because the website is limited to 20 people. So unless one person visit and leaves, when one person visit and leaves, then now this other person can enter, right? So that makes now traffic to the website to be very slow, very slow, right? So now AWS brought the idea of elastic load balancers. They brought the idea of elastic load balancers. What does an elastic load balancer do? Now, when traffic gets more, this is what AWS does. It replicates this computer, like this server like this, into two. Come over here, please. Look at what is happening here. This is a situation where this machine can hold 20 people. At any one time, this machine can hold 20 people, right? And at any one time, this one can also hold 20 people. Look at what has happened. Traffic became more, and more than 20 people wanted to have access to this machine. Let's consider that more than 35 people were having access to this machine. More than 35 people, they wanted to have access to this machine. Look at what happened. AWS made it such a way that the machines now separated into two. That means some sort of a division. They became two machines now were created, with each machine being able to have 20 people, and this machine being able to have 20 people. This machine is server 1, this machine is server 2. All of them have the same content, okay? All these two machines have the same content. You that wants to, this man here that is trying to have access to the machine, first of all lands but on a load balancer. Now that is what we are going to study today. He lands on a load balancer. What does a load balancer do? A load balancer now says that no, this machine is having already almost 20 people. Let traffic not be going to this machine too much. Let me send some other people to go to this machine. If there are already 35 people that are coming here, the load balancer will now equilibrate the traffic so that one machine should not be having too much traffic, and reduce also the time for people to be waiting. So a load balancer is always present in front of servers so as to equilibrate the way traffic flows to those servers. Okay, so if you are ever asked what is the role of a load balancer, your response is a load balancer is always there to make sure that traffic is equilibrated to all the machines and all the servers that are hosting the website or the application. That is the work of the load balancer. It is just there to make sure that no machine is overcharged, no machine is too much having weight. Traffic goes to one machine, that machine can go down. So it equilibrates the traffic and makes the traffic go to different machines at a particular time. Okay, so that's the work of the load balancer. Now we are going to go to auto scaling and all the like. You will discover that you can start your saver with one particular saver like this, and then if traffic becomes more, the saver will separate into two of them will be created like this, and a load balancer will be created in front of them. And as the traffic is becoming more and more, the savers will keep separating, keep multiplying, right? The savers keeps multiplying. That is what they call elasticity in the cloud. They call it elasticity in the cloud. That means that there is no way that your system can ever get full, that it is too full for people to visit your system. There is just no way. Okay. I always, when I'm teaching this particular lesson, I'm always talking about a situation in which when we wrote the exams to ENAM, when ENAM was still the school that everybody wanted to get into that school, we wrote the exams to ENAM, and then what happened? At a particular moment, the results were released. We were about 10,000 of us that wrote that exams, and they announced it at 5 p.m. that the results are released and they are available at www.enam.cm. The guys had just this one saver that was available there, and they knew that more than 10,000 people wrote the exams. So with more than 10,000 people that are writing the exams with one saver, and you people are saying that anybody that wants to get the results should come online. That is how more than 10,000 people logged onto the website www.enam.cm. And when they logged into that website, the website crashed. You will log into the website and stay for more than 20 minutes before the website will ever open. So what was happening? The website had its own limit. Maybe just around 500 people could have access to the website at a particular time, but now 10,000 people wanted to have access to the website. What was the website now doing? It was waiting that one person should leave before it takes another one. Another person leaves before it takes another one. And so having access to that website was too slow. They did not have idea of the cloud. But in the cloud, what do we do? In the cloud, we decide and we make it such a way that the savers multiply themselves, auto create themselves, and a load balancer is here to make traffic flow to the savers equally. All right. So we are going to be seeing how to create a load balancer. So in order to create a load balancer, what do we need? We need to create at least two EC2 machines. Also, we need to create two EC2 machines, and then we create a load balancer, and then we see how that load balancer will function. Okay, so that's what we are going to be doing now. Guys, we are already entering into the real architecture of the cloud. At the beginning, we were first of all trying to do introduction and getting you hands on the tools that you need in order to be practicing. Right now, we are already starting the architecture of the cloud, what they call architecture. You are becoming solution architects. So this is what they call the architecture. So when you will be asked to create anything, you will need to draw it, you need to design it. It is an architecture that you are creating. So if they ask you to create an architecture which hosts 5 different savers with a load balancer in front of them, you should be able to first of all draw it before you start creating it. Because if you don't draw it, you can never create anything. You have to first of all draw it. Now, look at what I have drawn. I know that I'm going to create this saver, I'm going to create this saver, and then I'm going to create this load balancer. This is a load balancer, this thing from here like this. This is a load balancer. I'm going to create this load balancer in such a way now that when I ask information to this load balancer, it can either take me to this saver or it can take me to this saver. Is that clear? So we are going to see the different types of load balancers that we have. There are 4 main types of load balancers and all of them are playing their own different rules in different ways. Okay, so let's enter our notes. I'm going to give you a note to you. We are told that we have classic load balancer, application load balancer, network load balancer, and gateway load balancer. You have to learn in detail all these different load balancers in detail. So today we are going to take on classic load balancer. We are going to see what is a classic load balancer and how it functions. So a classic load balancer distributes equally incoming application traffic across multiple EC2 instances in multiple availability zones. This increases the fault tolerance of your applications. Elastic load balancers detect unhealthy instances and route traffic only to healthy instances. That is another work of a load balancer that I did not tell you. Look up here. Let's take for example that, let's consider that these two servers are available here, and then at one particular moment this server is down. This server can no more work. What will happen? This load balancer will immediately discover that this server can no more function, and it will stop any traffic that was going to this server and then pushes all traffic to this server. Okay, so the load balancer is some sort of very intelligent. Okay, it stops traffic from going to servers that are bad and send traffic only to servers that are good. What we'll be configuring it, you will see how it all functions. Okay, so the our bootstrap for creating our load balancer is available to you here. When you click this link, you will see your bootstrap. So let's go on and start our practice. Okay, we are going to create two EC2 instances, and those two EC2 instances are going to have two different server configuration for our practice session. Two different server configuration. Let me launch our instance. The first one is, I'm going to name it server 1. Server 1. A Linux machine, T2 micro, key pair, security group. Now know that we are creating the servers, so you should make sure that all your security groups should have the HTTP port wide open, because if the HTTP port is not there, your servers are not going to be accessible. So make sure that your HTTP port is open. Now I am clicking on advanced to go down to where I am going to put my bootstrap. Okay, here is my bootstrap script. Okay, let me write in my first script that server 1 is responding to call. Then I write in the second one that server 2 is up and running. Okay, this is the configuration for my bootstrap for server 1. This one like this, configuration for server 1, copy and paste here where there is user data, and then I launch my machine. Now I'm going again to create a second machine. I'm going to create a second machine. I'm creating it server 2. T2 Micro, Keeper, security group. I choose my security group. Then I put the bootstrap. Here is my bootstrap script for machine 2. I launch my computer. Now look up here. For us to have access to these two servers that we have just created, we have created two servers. This is server 1, this is server 2. Server 1 is already running. For us to have access to server 1, what do? We have to come and take the public IP of server 1 and then we run. We take the public IP of server 1 and then we run. Hoping that we will see our web page. We have a problem with our web page. So let's make sure that our security group is well constructed. Let's see whether server 2 is okay. Oh, server 2 is up and running. Now what is happening to server 1? Server 2 is up and running, but server 1 is still being initialized. There seems to be a problem with this. Okay, server 2 is up and running. Server 1 is still facing difficulties. Let's try to see what the heck is happening to server 1. Server 2 is having which security group? Def security group. Server 1 is having which one? Okay, you see where there is a problem with server 1. We did not assign a good security group to server 1. Okay, so in this situation you can never have access to your server. So this error, I hope this error will make those of you who, when you create your EC2 and you cannot have access to them, to learn that when you do not have access to your saver, the first place to check on is always your security group. Look at this security group like this. It is not having the HTTP port open. It is not having the HTTPS port open, nor any other port for saver. So what can we do? There is something we can do. We can open the saver, the security group, click on the security group. How do I click on the security group? I'll be sure where I was. Let us take it gradually for some of you to see, because I know that so many people will be having problems with this very networking. All right, look at where we are. We are normally, it is always in details where we copy our public IP in details here. So from details here, you come to security. When you come to security, you will see a security group here. You click on the security group to open, and then when you come to this security group, what do you see here? You see that type all traffic and all whatnot. Okay. So what do I have to do? I have to edit inbound rules. I click on edit inbound rules, right? When I click on edit inbound rules, what do I have? Add rules. When want to add rule, the first rule that I'm going to add is I'm going to open the SSH port. That is the port that is being used by Linux machines. I open the SSH port. The second thing that I want to do is I open the HTTP port. I open the HTTP port. The third thing I will need to do is I open the HTTPS port. HTTPS port, right? I know that when you have the question that, but I have already opened all traffic, why is it not just picking up? Some are like that. You open all traffic, they will not pick up. Okay. So with this, let us save and make sure that our security group has been well configured. We have that we cannot from anywhere. Okay. Okay, we delete this one and we run open all traffic, internet from anywhere, and you save. We hope that we have configured something now, and we are hoping that saver 1 should run. Okay, you see our saver 1 is running now very okay. Saver 1 is responding to call. and then our server 2 is up and running. So let me zoom a bit for you to see. You see server 2 is up and running, and server 1 is responding to call. So those are our two servers. Now we start our load balancer journey. How are we going to put our load balancer? How is the load balancer going to work? Now I want you to take a look at this. For us to get into this server, we need to put the public IP of the machine here. And for us to get to this server, we need to put the public IP of the machine here. Now, but look at what a load balancer is going to do to us. A load balancer now is going to have one position, one point from which you can have access to this machine and from which you can have access to this machine. So it will not be again neither the IP address of this computer nor the IP address of this computer, but it will be a DNS of the load balancer that you are going to be using to have access to these computers. You will no more have access to this computer by its public IP, and you will no more have access to this computer by its public IP. You are going to have access to the two computers through the elastic load balancer. So this is what we have, please. So you come down, if you look at your left side of the screen, you will see something there, load balancer below. You see load balancer there. You click on load balancer. The load balancer is heavy to create. Now create load balancer. You look at something here, create load balancer. We said there are different types of load balancer. We have application load balancer, we have network load balancer, we have gateway load balancer. You come right down, you see classic load balancer. Classic load balancer is already obsolete. AWS is not going to be using classic load balancer again, so we are just learning it for learning purposes. So here is classic load balancer. So you come up here, you will see the first three load balancers that are still under use. Then you see classic load balancer under below here. So you click on create classic load balancer. When you click on create, they will ask you to give the load balancer name. I will give it balancer 1. That's the name of the load balancer. Okay. I click on assign security group. The same security group that I assigned for my machine, I should assign to my load balancer. All right. I can assign my dev security group. I click on configure. These are the various security groups that are with you, please. So you choose from there. Click on configure security settings. When you reach this step, you continue moving ahead. Configure health check. There is a very important aspect about this health check that I would like you to understand what you are configuring, because when you will be doing your configuration, they will ask you that you are going to be using all these. Here we have something. Let me zoom it for you. Here we have protocol, we have ping port, we have ping path, then we have response time out, we have interval, we have unhealthy threshold, and then we have healthy threshold. So let me explain to you the meaning of all those things. Okay, let's start with response time out. HTTP is the internet protocol, the port is 80, and then the path is index.html. This one is always there like that. Now, this is where you are going to be configuring when you will be making your computers. This is what you are going to be doing. You are going to be deciding the response time out. So what is the response time out? What will you be deciding for the response time out? The response time out, because load balancers check the health state of machines, the response time out is the time to wait for a machine to respond. That means the time that you are going to wait for that machine to respond. Without which, if the machine does not respond, the load balancer will conclude that the machine state is unhealthy. The maximum time is 60 seconds and the minimum time is 2 seconds. That means that what? The response time, what you are going to put here, is the time that this load balancer is going to wait when it sends an information. When the load balancer sends an information to this machine like this, to this server like this, it is going to wait to see that the response comes back to it. So if you put two, here, then the load balancer is going to wait for 2 seconds. And if there is no response from the machine, the load balancer will then declare that that machine is bad. If you put 5, the load balancer is going to wait for 5 seconds. If there is no response, then it is going to declare that that machine is bad. If you put 10, it is going to wait for 10 seconds. So the highest time that it can wait before it declares the state of the machine as unhealthy is 60. All right, that is that about response time. Then we have interval time. So what is the interval time? It is the interval is the time the load balancer should wait before checking again on the health state of the EC2 machine. Minimum is 5 seconds and maximum is 30 seconds. Now, imagine the load balancer needs to tell you that a machine is bad. After going and checking the first time, should it just come and tell you that the machine is bad? Sometimes the machine is not yet bad, it is still trying to boot up. So this is what the load balancer does. It goes and checks the machine whether the machine is back, and then if it does not see that the machine is responding, it comes and waits. After it waits for some time, it goes back again and check again whether the machine is responding. If it goes and check again and the machine is not responding, it comes back and wait. So the time for it to go and check and come and wait is 30 seconds. The highest time is 30 seconds. So what you put here will determine how often the machine is waiting to declare that a load balancer is waiting to declare that a server is down. Okay, so the interval is the time that the machine takes before within request to declare that a server is down. We have unhealthy threshold. What is unhealthy threshold? The metric determines how many times the system should check on an EC2 instance. This one just tell you that if you check 3 times, 4 times, 5 times, and the machine is not responding, then the machine is bad. So if you put 2 here, if you see 2 here, that means if you check 2 times and there is no response, that then the server is down. Then healthy threshold. Healthy threshold determines how many times the system should check before declaring that the EC2 is healthy, right? If it checks the first time, you can also check a healthy EC2 and the EC2 is not healthy, but when it checks the first time, it comes with a false report. A false report that what? Have you ever gone to the hospital that you are sick and then by the time they do you test, they discover that there is nothing wrong with you, but you are feeling that you are sick? That means that test is a faulty test, a faulty result. So you can check the first time and the machine is saying that it is okay, but in reality the machine is not okay. So you need to check 2, 3 or 4 times to conclude that the machine is okay and running. So this is the most important place in configuring your load balancer. When you finish configuring all this, then you come now here, you click on add to EC2, right? Now these are all my EC2 machines that are running. I'm going to create the 2 EC2s that I wanted to make them be under that load balancer. It was server 1 and server 2. Those are the 2 EC2 machines that I want them to be under the load balancer. Okay, then next, tags. We are going to talk about tags in future classes. Tags is just to tell you, give you a particular nomenclature. Review and create. So this is all the configuration I have made. So I need to create my load balancer now. Okay, my load balancer has been created. Okay, my load balancer has been created. So I go now to load balancer. I will see my load balancer here. Here is my load balancer. It is already available. Now, how can I use my load balancer in order to get access to my savers? Click on your load balancer. You click on your load balancer. When you click on your load balancer, you see something here like DNS name. DNS name. Instead of using public IP address now, you are going to use this DNS address. Copy and end here. You are going to use this DNS address. You copy this DNS address now, you put here and you paste. Enter. We hope we did something right. Let me check on our DNS that we have copied. Balancer. Our DNS isn't responding. Are we sure about our DNS? Let's copy it again. This is the right one. Is something happening to our DNS? Okay, it is functioning now. Okay, look at what is happening to our DNS. It took some time to take off. So this is our DNS now. We do no more have but a public IP address there. We have but a DNS. Now, look at the magic of a load balancer. Let me zoom it, please. We are in server 2. We are in server 2. Now, when we refresh, if we refresh, see, we are now in server 1. We are now in server 1. We refresh, we are in server 2. We refresh, we are in server 1, right? So from this load balancer now, from this particular load balancer, this elastic load balancer, we can either have access to you or we can either have access to you. So we do not need again the IP address of these two. No, we do not need it. This load balancer plays the work of spreading traffic. Okay. All right. That is for elastic load balancer. Does anyone have a question with regards to elastic load balancer? You unmute and then you talk. Is there anyone having any worry?
Good evening, sir.
Yes, good evening, Declan.
Uh, I don't have a word. I just want to know the full meaning of that DNS. If I didn't have it, or if it was in the previous class and I did not come across it.
The full meaning of, when you look at things like this one, I mean,
Yes.
these are things that Google is there for you now, Declan.
Okay. Yes, I was just being a little bit curious. This one yeah. Okay.
Yeah, a DNS is a domain name service, right?
Okay. Yes, sir.
Yeah, when you come to Google and you
Mm-hmm.
ask what is, it's as simple as, sometimes some people suffer with questions when Google is there for them. What is DNS, right?
Mm-hmm. Yes.
It will tell you that it is a domain name service. What is it? This is it.
And
Domain name system, right?
yes, sir.
Yes. So it is a domain. What will come to, do you know what they call a domain? Like your website. Take a look here. There is a website. When you want to enter Amazon, you AWS, you go through. Look at, we have aws.amazon.com, right?
Yes, sir.
This is a domain, right? This is their name, right?
Yeah. Yes, sir.
That is their domain. We do not use IP addresses in order to get access to their system. No, we use this their domain name, right? So
Yes, sir.
there are companies that give access to all these domain servers, domain name system. We are going to come to all of that and we'll explain how they function. Okay.
Oh, okay, so thank you.
Any other question? All right. Declan, I saw your performance and I was very happy with your practice. I was happy that you are
Thank you, sir.
practicing and getting frustrated and practicing and never getting tired and practicing. It's very important to do
Yes, sir.
that. When you do that, you learn the hard way and you always you'll be an expert very, very soon, because when you have gone through a lot of difficulties and a lot of mistakes, those are the same mistakes that those who are coming behind you, they will be going through it and you'll be solving them now like a pro. And
That's true, sir.
that is just the way the learning comes. Okay, just keep doing what you are
Yes, sir.
doing. Just keep doing what you are
Thank you,
doing,
sir.
and in no time you'll discover that everything is just as easy as anything. All right.
Thank you, sir.
I hope we will take time and go through our practice of elastic load balancers very well, please, because the beginning of the architecture starts from here. And if you don't start grabbing that architecture very well, you are going to get lost. And when you get lost, you will not understand what is happening anymore. So please, everybody, try and make sure that you understand this architecture as starting from these elastic load balancers. We are going to start adding elastic load balancers, network load balancers, gateway load balancers, and then we are going to be integrating other resources and making the architecture now really looks an architecture. So this is your real, we have started now your real program. The introduction is now over. So please be very careful right now. Okay. So I hope you practice very well. See you guys tomorrow. Good night.